The OTP interop org on GitHub has several packages for running Elixir on Apple platforms. And here we have a small sample application. The real-time chat gen server joins a process group called chat, and then it can send messages to all the members in the group. To run this on an iPhone, we'll use Elixir Pack. Elixir Pack provides a mix task that builds OTP for Apple platforms. First, you provide a path for generating the Swift package. We'll call ours real-time chat. Then you pass a list of target platforms to build OTP for. Here we're building for the iPhone simulator on Apple Silicon. But you can also pass multiple targets and it will build for all of them. Finally, we pass a path to any custom NIFs we want to statically link. But for this demo, we're just going to build for the iPhone simulator on Apple Silicon. This will build OTP and its dependencies for the target platforms, make a mixed release of our Elixir application, and then assemble a Swift package. Now we can integrate this into our Swift app. First, we'll import real-time chat, the package it generated, and then we'll use the auto-generated real-time chat class, and we can pass the name of the node, iPhone, and a cookie that we want to use. And when we launch the application, we'll see in the Xcode logs from our Elixir application. And since we're using EPMD, we can do EPMD names, and there we go. We see the iPhone node running. Now we want our Swift and Elixir applications to be able to communicate on device. For that, we're going to use Swift Erlang Actor System, which allows a Swift app to act as an Erlang node. First, we'll import distributed and Erlang Actor System. Distributed is part of the Swift language, and Erlang Actor System establishes the protocol distributed will use for actors to communicate. Next, we'll create a protocol marked with @resolvable. This tells Swift the structure of an actor defined somewhere outside of this app. In our case, we're referencing the real-time chat gen server defined in our Elixir application. Defining the send function will allow our interface to cast a send message to this gen server. Next, we'll define our own distributed actor, and you can think of instances of this actor as a process in Erlang. This actor will join the chat process group so we can display the incoming messages. So we specify that it can handle process group style calls. And then we'll define some structures for storing a list of messages. And then finally, we'll add the receive method, which matches the signature of the receive message sent to all processes in the group, and we'll add to the message list when the receive is called. So now we can use the types we created when the app launches. So first we'll create an instance of Erlang Actor System. This is equivalent to a node. We give it a node name and a cookie, and we'll use the same cookie for all of the nodes that we create here. And then we can create our receiver on that actor system, and we'll have it join the chat process group so it can receive messages. Then we start up our Elixir application called real-time chat, like we did before, and we name this node iPhone and use that same shared cookie. And finally, we'll resolve the real-time chat gen server running on that Elixir node using its registered name, elixir.realtimechat, and the name of the Elixir node as the node name. This will let us send messages to that gen server. So we have all our logic in place. Now we can build an interface around it. So we'll have a list for our messages, and we'll grab the messages from the receiver to fill that list. Then we'll add a bottom bar with a text field and a send button. And when the send button is pressed, we'll cast the send message to the Elixir node's real-time chat gen server and clear the text field. And we'll make one small tweak to our gen server to connect to the client node running on Swift. And typically you wouldn't be able to use EPMD on a physical iPhone, and you would connect nodes more deliberately, but here we're just going to use EPMD. So now when we run our app, we can connect to the iPhone node from IEX, and then send a message to all processes in the group. And we see the message pop up on the iPhone. And then we can send a message back from the iPhone to the console, and we see it show up there.